You're listening to a Frequency Podcast Network production in association with City News.
Sometimes the world just moves too fast for a podcast. And when it does, it's usually not a great sign. I will give you an example. A little over a week ago, there was some very troubling news from both the Arctic and Antarctic.
Typical mid-March values for Antarctica are in the minus 50s, but what was recorded on March 17th was utterly astonishing, breaking station monthly records, but also achieving the hottest temperature of all time for the continent.
Scary, especially on the heels of an IPCC report warning that we're already experiencing the very real impacts of a changing climate. So naturally, like we do around here, we called a climate scientist, and we asked him what was going on, and that was the conversation that you would have been hearing today. Except, over the weekend,
an ice shelf the size of New York City has collapsed in East Antarctica. Scientists say it's concerning because the region where it happened was thought to only be mildly affected by climate change.
So, yeah. You know that the climate is changing, of course you do. Did you realize that it's changing so fast that you can't hold on to a conversation about it for 4 days without another catastrophic event? That one was a shock for me too. But perhaps it's better this way. Maybe this is what we need, to be hit over the head again and again until we finally understand the seriousness and the speed of what's happening here. Or maybe not. Maybe that just scares the out of all of us. And what we really need is to understand what's happening, how it's happening, and what we can do to fix it without flipping out. I'm Jordan Heath Rawlings. This is The Big Story. Simon Donner is a professor of climatology at the University of British Columbia. He studies how climate and climate change affect society and the environment. And we are speaking to him once again. Hello, Simon.
Hi there.
Can you fill us in on what's been going on? I guess at both poles over the past couple of weeks, it's been eventful.
Well, we had record heat waves in both the Antarctic and the Arctic at the same time, which is quite unusual. But as well, there was one ice shelf, off of the coast of Antarctica that broke off of its connection from land and disintegrated into pieces of icebergs, basically.
And I'm going to get you to get into the science of what's happening with both of these things. But first, the obvious question, are the two connected? Do we know anything about that?
No, the fact that it was warm at the Arctic and in Antarctica at the same time was just a little bit of a fluke. This can happen. Two parts of the planet can have unusual weather systems at the same time. What was remarkable was the numbers, there are places in Antarctica that were 30 degrees Celsius above normal, 40 degrees Celsius above normal in some spots in the Arctic. Now, of course, warm is a relative term. It was still well below freezing in Antarctica, but instead of being negative 50 Celsius, it was negative 15 Celsius in many places.
So let's start with those numbers then. They are pretty stunning. They made a lot of headlines around the world. What went through your mind when you started seeing them?
Well, for someone like me that's been studying climate change and its role in extreme events around the planet, I wish I could say these sort of events were completely surprising, but it's just more pieces of data, confirming what scientists know, that the planet is warming. And one of the ways we're experiencing that warming is by seeing these extreme events. I will say that the magnitude of it really kind of blew me away. We're talking about weather stations that have recorded the coldest temperatures on Earth. Vostok, the Russian station in Antarctica, has the record for the coldest temperature on Earth. Negative 89 was measured there once, and it was 39 degrees Celsius above normal there. It would be like it suddenly being, 45 degrees Celsius in March in Vancouver. It's completely crazy temperatures.
Do we know what factors were at play? I mean, obviously, we can talk about the warming of the planet in general, but what weather factors or climate factors were in play to cause these temperatures?
Well, ironically, the weather system that caused this warm event in Antarctica is actually similar in some ways to what was happening on the west coast of Canada here last fall.
Mm-hmm.
So basically, a weather system got pushed far into the continent, further than it would normally get, and effectively got kind of stuck there because of the way the atmosphere is circulating. And so the system was the tip of what atmospheric scientists call an atmospheric river, or here on the West Coast, we sometimes call a pineapple express. The way the air is circulating the atmosphere is bringing like a river of moist air from lower latitudes towards higher latitudes. So it's bringing in clouds and moisture into the region. And so this happened, it penetrated a fair ways into the continent of Antarctica. And then the next weather system came along, and it's what we call a blocking high pressure system. And that kind of stops air from escaping. So it kind of trapped the moist weather over Antarctica, which is unusual. Antarctica is usually very dry. And that meant that it was cloudy and damp for longer than normal, and the heat wasn't as able to escape. And so that's where you ended up, the temperatures kept building until they really shattered some records.
Has that ever happened before? I'm not talking now about kind of the unprecedented numbers that you mentioned, but those kind of weather systems penetrating that far in and the effect that it would have.
Yeah, the idea that this can happen during what is effectively the beginning of the fall in Antarctica is not that unusual, that it would penetrate that far into the continent, and you'd be seeing the influence at the few inland weather stations, basically places where scientists are working, or at least there's an automated weather station, is highly unusual. I mean, Antarctica is not only cold, it's also extremely dry. It's effectively a desert, and it usually has what we call sinking air, like basically the atmospheric conditions that are similar to the world's great deserts. And in addition to that, it's also very high up. Antarctica is mountainous and obviously covered in very, kilometers thick glaciers of ice. And so some of these weather stations we're talking about, they're not only at very high latitudes, they're at very high altitudes. They're, thousands of meters above sea level as well. Mm-hmm. So just to see these records happen at a station that's 3,000 meters above sea level is pretty weird.
And at the same time, we were also seeing similar temperatures at the North Pole in the Arctic. And I guess my question is, I know they're not connected, but that's a really strange coincidence. Was it the same kind of weather system doing that?
Yeah, there was a somewhat similar weather system. I mean, effectively what we have happening in our latitudes was the jet stream, which brings storms towards places further south in Canada during the winter. It is a big wavy weather system that dips far north and then again back far south. And just because of the position of the jet stream, it was basically bringing warmer weather into the Arctic and some cooler weather to some areas further south. We've experienced things like this a lot over the winters over the past 20 years. So it wasn't that unusual that it happened. Again, it was just the magnitude of the numbers that was so surprising.
Before we move on to talk about the ice shelf, this is something we talked about with the disasters last year in BC, right? Whether or not it was quote unquote caused by climate change or just a coincidence, something that happens rarely, but sometimes.
So for climate scientists, there are actually techniques that can be used that have been developed over effectively the past 20 years to try to identify, how much climate change contributed to an individual event. And we do this by comparing the observations to what we can simulate with a climate model, and then looking at whether the event is as likely to happen in a simulated version of the climate that includes greenhouse gases being added by human activity and one that doesn't. And when we do these sorts of experiments, basically, you can pull the numbers out of those experiments to try to say how likely an event was with and without climate change. Now, the challenge is that with what's had just happened in Antarctica, it was too recent. We don't have enough data to look at to do that type of forensic analysis. But, the heat dome in British Columbia last summer, scientists were able to do a forensic analysis within a couple weeks of that event happening and found that it's much more likely to happen, hundreds of times more likely to happen because of adding greenhouse gases to the atmosphere, because of climate change.
In terms of the headlines that came out of those temperatures, is it accurate the way, and again, I'm not trying to speak for everybody who wrote about it, but just, the way they were being portrayed on social media and elsewhere was like a sign of impending doom, essentially. Like it's almost zero in Antarctica. This has never happened before. It's the end of the world, or it's here way before we thought it would be. What's your analysis of if those are appropriate and if they accomplish the right thing in terms of educating people on the crisis that we're in?
No, it's such a great and important question. I feel like we both over and underreact to news of extreme weather. On the one hand, I think we fail to recognize sometimes, how climate impacts from extreme events are increasingly complex and difficult to manage, and that we really need to think seriously about how we're going to prepare for them. But on the other hand, they've kind of gotten turned into a bit of kind of disaster porn. Mm-hmm. And as a result, people, I think, are falling into the prey to assuming that fear is going to be a good motivator. But in general, I mean, when you need to make a big decision in life and certainly in politics, you need to have something to run towards, not just something to run away from. And I wish that in addition to talking about extreme weather, which is important given how it affects people's lives, we also were talking about climate change solutions. Why are electric vehicles a good idea? And how do we connect to people individually? Like, how could the solutions to climate change, improve your life, rather than just talk about the extremes around the planet as if there's nothing we can ever do to stop climate change. I worry that fear is not always the best motivator.
We had these incredible spikes in temperatures. As I'm speaking now, I guess about a week and a half ago, and they receded. But tell me about what this ice shelf that we're about to discuss, first of all, is, before you tell me about what happened to it. Where is it? What do we know about it?
The language around sea ice, ice shelves, ice sheets, glaciers, it gets really confusing.
Yes.
An ice shelf is ice that's floating on the ocean, but is connected to the glaciers on land. So if an ice shelf melts or just disintegrates, the sea level doesn't actually change, because this is like melting ice cubes inside a glass of water. You melt the ice, the level of the water doesn't really change very much, right?
Oh, that's interesting. I never would have seen it like that.
Right, but here's the thing. Ice shelves, however, are extremely important to future sea level rise because they're kind of like plugs in a dam. They hold the glaciers on land back from sliding into the ocean. And so scientists worry about the collapse of ice shelves in Antarctica because with fewer ice shelves, we could see an acceleration of melt on land contributing to sea level rise.
So which ice shelf are we talking about today and what happened to it?
So this particular ice shelf is called the Conger Ice Shelf. It's not of like global significance. And so although it's large compared to, say, the area of a city in North America, people are saying it's about the size of New York City, the glacier that it's sort of buttressing or holding back is small by the standards of Antarctica. What's unusual about it disintegrating, it is in East Antarctica. And most of what you hear in the news and what scientists are focusing on around melt in Antarctica is in the west part of Antarctica, the West Antarctic ice sheet. And so this was quite unusual. You don't tend to see these things happening as much on the eastern side of Antarctica. And so the fact that it collapsed surprised a lot of scientists how quickly this happened.
It's really interesting that these two events, or three, I guess, if you separate the two poles, came so soon after the latest IPCC report on, the severity of what's happening now. This seems to be almost ahead of the fairly dire schedule that report laid out.
Yeah, I was an author on the most recent IPCC report, and one of the things that's hard not to think about is that it feels like the climate is changing faster than we can do the research and write the reports.
Yeah.
So I'll give you an example. The heat dome and heat wave of last summer here in British Columbia, as well as the horrible flooding we experienced in the fall, those are not talked about in the North America chapter of the report. And the reason is the report, we were finishing the report last summer. So I was actually working on the report during the heat dome. And so it is tempting to say, listen, the climate's changing faster than we can handle any of this. I mean, I think what really matters here is that we're seeing as the climate is warming, we're pushing above sort of thresholds more often. So we're seeing heat waves above certain levels more often. We're seeing rainfall, extreme rainfall above certain levels more often. And what we see is when you push it beyond some thresholds, the risks of those extreme events become more increasingly complex. And as I was saying before, really difficult to manage. What we had happen in the fall here in British Columbia was essentially like a multi-impact event, because yes, it was driven by a very, very wet atmospheric river that caused flooding. But why did all that rainfall turn into flooding? Part of the reason is we'd have a heat wave earlier in the year that had caused forest fires, loosened a lot of slopes, and probably helped contribute to a lot of the landslides. And so it's these sort of compound events that we're starting to see that the IPCC report warns about. And it's kind of fascinating and somewhat disturbing to me that kind of what was being warned about in the report happened after we, sent it in to actually be printed.
And these most recent events then, what kind of compounding factors or I guess chains could they begin? If we're taking these extreme temperatures and the collapse of the shelf as the beginning of something, what are the next potential consequences down that road?
Well, the big worry about anything affecting, rainfall, certainly in Antarctica, warm temperatures in Antarctica, is how it's going to affect the melt of the ice sheets, the ice that's on land that would contribute to sea level rise. And it does look like this sort of atmospheric river event that caused the heat wave in Antarctica probably played a little bit of a role in the timing of the disintegration of the Conger ice shelf. But one thing to know is that ice shelves, because they're floating on the ocean, a lot of the melt of them is actually happening from underneath, not from up top. So they're melting in part because the ocean is warmed. And so slightly warmer water is in contact with the ice shelf and accelerating its disintegration. And the reason I think that matters is because it's a way of saying that, it can be below freezing in the air, but if the water's underneath the ice sheet's warm enough, you can still be causing some melt.
Right.
And so I think the big worry is, as the planet keeps warming, it's the decisions we're making in the next few decades that are going to determine how much the ocean warms for many, many, many decades to come. And so really kind of the decisions we have to make over the next few decades about our greenhouse gas emissions, they're going to be determining what the sea level's like on the planet for really centuries or millennia to come. So it really is why this is a crisis, because we have to make choices now to decide what the future of the planet's going to look like.
Speaking of those choices, I want to ask you, beyond, and we've done episodes on this, and I wish any episodes that anybody had done had a difference. But in terms of curbing emissions, adopting clean energy, electric vehicles, as you mentioned, we kind of know the core things of what we need to be doing as a society. What I'm wondering is, from a scientific standpoint, is there anything that can be done specifically to protect those ice sheets and to keep them frozen? Like, are there any practical measures we could try to take?
So there are some examples in the Alps in Europe where people have been trying to protect small areas of glaciers that are of like local cultural significance by covering them in like a cloth so that they can't melt as much during the summer. But that's not even feasible at the scale of a glacier in an Alps. It's certainly not feasible to do all over Antarctica. Right. And so there really isn't a direct intervention in that way. What this is about, and every climate impact is about, it goes back to the source of the problem. The more we reduce emissions, the less the planet's going to warm, and the less people are going to suffer.
The last thing I'll ask you is something I think I end up asking at the end of every one of these talks, which is, what would you like the average Canadian or the average listener to take away from these dire headlines? Quite frankly, we're often told, okay, well, you should be eating less red meat. You should go buy an electric vehicle. I feel like we keep missing out on the bigger picture here whenever we have these discussions.
And I'm with you. I do worry sometimes that we report on, these enormous changes happening in the planet. An ice shelf just broke up in Antarctica. And then we come home and tell you, okay, so don't eat a steak for dinner. That the solutions that are sometimes being offered don't seem commensurate with the scale of the problem. But the truth is, this is the world, the biggest collective action problem in world history. We all need to act, and we need to do so collectively to possibly solve it. And so that means, for the average person, we need to talk to each other about this. And we need to talk about how we collectively can sort of transform the way we all are living, not just the decisions you are making, and how government policies can help with that so that we can move to, a low carbon economy, so that we can rely on electric vehicles, using electricity to heat and cool our homes, et cetera. And to do that, I think we need to talk more about the benefits of the solutions, not just about the costs of inaction. And, the example I always think about is that most of the drivers of climate change, burning fossil fuels, they're also the cause of air pollution, like smog. Now, air pollution killed as many people last century as the world wars combined. It kills millions of people each year. And if we take the actions to address climate change, we would also reduce most of the world's air pollution, like we'd save millions of lives. And we don't talk about this enough. We don't talk about all of these benefits, other benefits of like good climate actions. And I feel like if we did so more, if people recognized that climate solutions were good ideas regardless of climate change, we might be able to get more traction. We might be able to give the governments more motivation.
Simon, thank you for this. Maybe we will have that conversation sometime soon.
Thanks so much.
Simon Donner of the University of British Columbia. That was The Big Story. For more from us, head to thebigstorypodcast.ca. You will find a lot of climate change reporting on there. I know, I wish we could quit doing it too, but guess what? It's not going away. You can talk to us on Twitter at TheBigStoryFPN. Tell us how much you love or hate when we cover climate change. Tell us how depressed we make you first thing in the morning. It's okay, makes me depressed to record these episodes. You can email us, TheBigStoryPodcast, that is all one word, at rci.rogers.com. Let us know what you think. Find us in any podcast player that you prefer: Apple, Google, Stitcher, Spotify, the usual suspects. The one I use right now, anyway, I switch them up all the time to experiment with them, is Castbox. You can also ask for us on any smart speaker you like. Just tell your smart speaker to play The Big Story Podcast. Thanks for listening. I'm Jordan Heath Rawlings. We'll talk tomorrow.